Researchers at EPFL have developed a drone equipped with avian-inspired legs that can walk, hop, and leap into flight, significantly broadening the variety of habitats available to unmanned aerial vehicles. The expression, "as the crow flies," denotes the shortest distance between two sites. Nevertheless, the Laboratory of Intelligent Systems, LIS, directed by Dario Floriano at EPFL's School of Engineering, has interpreted this term literally with the development of Raven, robotic avian-inspired vehicle for various environments. The multi-purpose robotic legs, inspired by perching animals such as ravens and crows that often transition between aerial and terrestrial settings, enable autonomous takeoff in areas previously unreachable by winged drones. The design of Raven seeks to optimize gait variability while reducing weight. Motivated by the dimensions of avian limbs and extensive observations of crows on the EPFL campus, Shin engineered a bespoke, versatile pair of avian legs for a fixed-wing drone. He employed a synthesis of mathematical models, computational simulations, and experimental iterations to attain an ideal equilibrium between leg complexity and total drone weight, 1.36 pounds. The resultant limb maintains heavier elements near the body, while an amalgamation of springs and motors emulates robust bird tendons and musculature. Lightweight avian-inspired feet consist of two articulated components that utilize a passive elastic joint, facilitating various postures for walking, hopping, and jumping. Translating avian legs and feet into a lightweight robotic system pose design, integration, and control challenges that birds have adeptly addressed through evolution. The study has been published in Nature. Robots previously engineered for ambulation were excessively heavy to execute jumps, but those created for jumping lacked appropriate feet for walking. Raven's distinctive design enables it to walk, navigate terrain gaps, and leap onto surfaces elevated by 26 centimeters. The LIS researchers collaborated with Auke Eichspiert from EPFL's Biorobotics lab and Monica Daly from the Neuromechanics lab at the University of California, Irvine, to modify avian biomechanics for robotic locomotion. The findings not only clarify the costs and advantages of robust legs in birds that often shift between aerial and terrestrial environments, but also propose a lightweight configuration for winged drones, capable of traversing rugged terrain and launching from confined spaces autonomously. These characteristics facilitate the deployment of drones for inspection, disaster mitigation, and delivery in restricted environments. The EPFL team is currently enhancing the design and control of the legs to optimize landing across diverse situations. What do you think about the future of bird-inspired drones? Could they revolutionize the way we use drones? Let us know your thoughts in the comments below. Thanks for watching.